Hello, this is Hui. Welcome to watch my video, C++ Programming on Linux. You may have seen in our previous videos on TCP network communication concept, where all examples utilize TCP blocking model. In this short video, we'll dive into the concept of TCP non blocking model. The example of this video, it will be updating an existing blocking TLS client C++ program to non-blocking TLS client using OpenSSL TLS libraries. Here, the Linux environment we're using is a Ubuntu 24.04. OpenSSL library version is version 3.0.13. The OpenSSL library manual is available on its documentation website. On this channel, we have created video examples built on top of OpenSSL version 1.0. There are significant changes between OpenSSL 1.0 and 3.0. The OpenSSL manual page and the OpenSSL 3.0 migration guide is an excellent starting point for grasping key concepts and migrating your existing application to OpenSSL latest version. Back to our Ubuntu Linux environment. Here we have two C++ programs from previous video: OpenSSL TLS client.cpp and OpenSSL TLS server.cpp. OpenSSL TLS client.cpp is a TLS blocking client example, while OpenSSL TLS server.cpp is a basic TLS echo server. In today's video, in order to concentrate on the concept of no-blocking model, we are going to update the existing TLS blocking client example to be a TLS no-blocking client. First, we will compile and testing these two programmers. The certificate and the private key were generated using OpenSSL command. It has been demonstrated in previous video. To save time, we will skip this process now. We will, however, include the certificate generation command in the video description for your reference. We make OpenSSL TLS client, OpenSSL TLS server. Now program has been compiled. This is our client executable and this is our server executable. To run the test, we are going to use two terminals. Top terminal run the TLS echo server. First argument will be the port number 1234. Second argument will be the certificate. My X509 cert.pem. Third argument is private key. My private key.pem. Now our echo server started listening on the port number 1234. Bottom terminal, we're going to run our client host name, port number 1234. Now we are going to type in a message from the client sent to the echo server and echo back. This is Hui test TLS blocking client message 1. The message has been sent to the echo server, so echo server returned the message back and our client received the message. Second message, this is the second Hui test TLS client blocking message 2 sent to the server and echo back and the client received. Back to our Linux environment. we're going to create a new program. OpenSSL TLS Non Blocking client.cpp. We're going to import from exist OpenSSL TLS client.cpp. R OpenSSL TLS client.cpp. Now we have imported from blocking client to this new program. The usage will no change to command line argument, the host or URL, and the port numbers. Create SSL CTX and SSL object process will keep same, add algorithm, load error string, and initialize SSL CTX object using function SSL CTX new client method create SSL object. The helper function create a socket BIO object in blocking model. We will now update it to generate a no blocking model BIO from blocking model BIO. Function create socket BIO. First look up the hostname, port number, address, create BIO socket, connect to socket using BIO connect. After that, add set no blocking models. If not success, which is a set sock equal -1, and if sock is -1, return none. Create a socket BIO field, and other than we return the BIO object. Right now, the BIO has been updated from the blocking model to the no blocking model. To process no blocking model BIO, we need to create two help functions. Function handle IO failure is used to check error returning code and decide whether to retry, forward, or fail the process. Function wait for activities using select system call monitor the socket BIO, wait if it is ready to retry. Function wait for activity using select system call monitor socket BIO, wait until the socket is writable or readable. Flag 0 is for read socket, 1 is for write socket. And the function handle IO failure is to check error and decide whether to retry, EOF forward, or failure. Here is the select system call on Linux menu page. The select allows a programmer to monitor multiple file descriptors, waiting until one or more file descriptor become ready for some class of I/O operations. Here, fdset is a structure type that can represent a set of file descriptors. And fd0, this macro clear remove all the file descriptor from set. fdset, this macro add file descriptors fd to the set. This function first argument is read fd file descriptor for reading, and the write of fd is the file descriptor for writing. Except fd is the file descriptor for exceptional condition. In fds, this argument should be set to the highest number of file descriptor in any of these three sets, plus 1. On success, select returns a number of file descriptor contained in the three returns descriptor set. Error, -1 is returned. Back to our editor. First, we are going to update function wait for activities. First, we declare FD set. It's a structure type of FD sets. NFDS is the highest number of FD plus 1. Sock is the socket FD. First, we use a function SSL getFD to get the sock object from the SSL object. NFDS equals sock plus 1, highest numbered FD. FD0, remove all FD from set. Add sock to the FDS. If flag, it's a right socket. First parameter is NFDS, the highest number of FD. Second parameter is read FD set, because flag is right, read FDS is none, right FDS, exceptional FDS, and the last parameter is timeout. We use none. First parameter, highest number FDS, read FDS. For the right FDS, none. Exceptional FDS, and the timeout. Finish write waiting for activities. We are going to update function handle IO failures. Function handle IO failure checks the error code and decide whether to retry forward or the failure. So return 1 is a retry. Return 0 will be EOF or forward. Return -1 is the failures. The return code, RET. Checks error code using function SSL getError. If error is SSL error won't read, this is a retriable error. 0 is for reading. If error won't write, this is also retriable error. 1 for write. Error 0 return. This is EOF forward error. System call error. Or SSL error, could be the certificate error. Return code should be the int integer, not void. After we made the adjustment of create socket BIO, our BIO is no blocking TLS BIO. We are going to set BIO associated with SSL object. First parameter is read BIO, and the second parameter is write BIO. Since read and write in the same socket BIO, so they're going to be same, and call the function SSL connect to initialize handshake to the server. In block model TLS operation, for example, handshake halt the application's execution until the operation completes. So here we can use if until complete will be returned to the program. No block model allows network operation to return immediately even if the operation isn't completed. Since our network socket BIO has been adjusted as a no block model, here we need adjust. If return code is not equal 1, it means operation not completed. We need to check the error and decide if we continue, retry, or fail. Handle IO failure function return 1. It means error will be retryable, so we'll continue, retry, otherwise print failed to connect to server and exit failures. Then we allocate two memory, receive buffer and send buffer. We use a loop. In each loop, we get the message from console and write into the send buffer. Get a message length of a send buffer. Use SSL write the message to the server, and use SSL read to read the message from the server. OpenSSL library 3.0 has two functions: write byte to a TLS SSL connections. SSL write EX and SSL write. Both functions are write bytes to a TLS SSL connections. The difference is SSL write return number of byte has been written to the socket, and SSL write EX return 1 for success, 0 for failure, and the number of byte write to the socket is on its fourth parameters. Here, SSL write EX function will return 1 for success or 0 for failures. SSL write are good for write operation in blocking model. In TLS no blocking model, it has to use SSL write EX function to check the error code return and decide if we want to retry or fail. Back to our editor. Command these two functions out, and we're going to use SSL write EX instead of SSL write. We declare two variables, send bytes and received bytes. After received, we are going to loop. First parameter is SSL object, SSL. Second parameter is the send buffer. Next is the length. The last parameter is the actual send bytes. If error, we need to check retryable or failure. If handle IO failure, return code is 1. It means we need to retry. Else, if error is not retryable, we just print a message, fail to write message to socket. Next, we are going to receive message from socket. Function SSL read EX. First parameter is SSL object. Second parameter is received buffer. Length is sent byte. Actual received bytes. If error, we need to check IO failure. Return code 1, it means to retry. Case 0 means EOS forward. Copy this line. EOF during the reading message. Failed during reading message. Finish the reading, we just print out read message, number of bytes received, number of bytes sent, and received messages. Next, make an adjustment for the SSL shutting down operation. SSL shutdown not equal 1. You need to check the error. If handle IO failure equals 1, retriable. Return code is 0, it's EOI forward. Then print a message, error shutdown. Now we have modified our program, update from TLS blocking model client to the no blocking model client. In order to better demonstrate how the no block model working, we're going to use a thread to demonstrate when the socket is ready or not ready for write and read. We include two header files, thread, stream. We create two functions. Function thread SSL send is going to send a byte to the socket. It takes two parameters. First is the SSL object and the thread ID to identify which thread sending the message. First, we print a message, thread SSL send. Memory for send buffer, we make a loop. For each loop, we're going to retry 5 times if error. First, prepare sending message. Declare string stream SS. Reset send buffer. From message ID, message number I. Copy string stream to the send buffer. Thread ID, message length, send buffer. For each sending message, we're going to check the error. First parameter is SSL. Second parameter is send buffer, message length, actual byte sent. If return code equal 1, it means a success. Otherwise, check the error. Return code equal 1, it's retriable. Print out message. Otherwise, print a message. Failed of sending message. Next, with thread SSL read functions. First, print the debug message. Thread SSL read has been invoked. Declare variable read bytes and the RCVD buffer. First loop, read 5 messages. For each message loop, retry 5 times if error. First loop, reset the receiving buffer. For each message, SSL read EX first parameter, second parameter receive the buffer, third parameter is the maximum size of buffer, last parameter is the actual read bytes. If return equal 1 means success. Otherwise, check the error. Case 1, retriable. Print out message, we are going to retry. Case 0 is UF. Case -1 or default. Copy this line, YY. The error. If RC equal 1, it means continue, otherwise break. For each success of reading, ID. Now we finish create 2 thread function, thread SSL read and thread SSL write. Back to our main function, create a thread. First, now we finish at just blocking client to no blocking client. We keep the typing message sent to server and also use a thread send 5 message and read 5 message to demonstrate how TLS no blocking client process working. We save our program. We compile our program. TLS server, the TLS no blocking client. Now program has been compiled. Here is our executable OpenSSL TLS server. This is our new updated OpenSSL TLS no blocking client. To test our example, we are going to use 2 terminals. On the top terminal, we are going to run the TLS echo server, port number 1234, my certificate, and my private key. Now our TLS echo server has started listening the port number 1234. Bottom terminal, we are going to run our client, host name, port number 1234. First loop input message. Type message. This is Hui test TLS no blocking client type message 1. Now this message has been sent to the server. Server replied back. Because of using this typing and send message, it's hard to see the no blocking client working. So we quit this loop and use thread to check client. So now we starting our thread, send 5 message 0, 1, 2, 3, 4 to the server, and the server reply back, check our client. The thread send message 0, message 1, message 2, send message 3, and send message 4. For the read thread, get error because it is not ready, so they retrying, and then we read message 0, message 1, read message 2. During the read message 3, they come to the retry again and read message 4. So this is how the no blocking TLS client working. Hello, this is Hui. Thanks for watching my video. Wish it is useful, and it's going to be great to have your feedback.